Hello children, welcome back to my channel. I am now dealing with ninth class maths. Areas topic I am doing, theorem 11.1. Parallelograms on the same base and between the same parallels are equal in area. This is one theorem children. Here parallelogram, see ABCD is one parallelogram and CDPQ is another parallelogram. These are the two parallelograms lying on the same base and in between the same parallels. Now you need to prove that area of ABCD is equal to area of CDPQ. So what is given to us? You have got parallelogram ABCD and parallelogram CDPQ lie on the same base CD and between the same parallels CD and BP. What is RTP? You need to prove that area of parallelogram ABCD is equal to area of parallelogram CDPQ. This we need to prove. Now let us see the proof. First let us take triangle ADP and triangle BCQ. In triangle ADP and triangle BCQ, in these two triangles, angle P is equal to angle Q because they are corresponding angles. PD or DP is parallel to CQ. So this becomes the transversal. These two are corresponding angles. Angle P is equal to angle Q. They are corresponding angles. Why? Because these two are parallel lines. This is the transversal. So these two are corresponding angles. Similarly, angle A is equal to angle B. They are also corresponding angles. Angle A is equal to angle B because they are also corresponding angles because these two are parallel lines. So these two are corresponding angles. Now we know that CD is equal to PQ. They are opposite sides of parallelogram. Also, CD is equal to AB. This is also the same reason. Opposite sides of parallelogram. Therefore, I can say that PQ is equal to AB. So what is PQ? PQ is nothing but AQ plus AP. Isn't it? PQ is nothing but AQ plus AP or PA. Let me write PA. AQ plus PA becomes PQ. Similarly, AB is nothing but AQ plus QB. AB is equal to AQ plus QB. So both the AQs can be cancelled. Therefore, we are getting PA is equal to QB. PA is equal to QB. So what you can say? See children, in these two triangles, these two angles are equal corresponding angles and these two angles are equal corresponding angles, and we could prove that these two sides are equal. So triangle ADP is congruent to triangle BCQ basing on angle side angle property. Angle side angle property. These two triangles are congruent. Now, what is area of a parallelogram ABCD? Area of parallelogram ABCD is nothing but area of trapezium AQCD AQCD plus area of triangle BCQ. Area of triangle BCQ. Similarly, area of parallelogram CDPQ is equal to area of trapezium AQCD plus area of triangle ADP. See children, in these two cases, RHS, trapeziums are same, triangles are also congruent. So what you can say, RHS in both the cases, RHS are equal. Why? Area of trapezium AQCD plus area of triangle BCQ is equal to area of trapezium AQCD plus area of triangle ADP. RHS, they are equal. Therefore, what you can say? Area of parallelogram ABCD is equal to area of parallelogram CDPQ. Hence, proved. This is the proof for this theorem, children. Once again, let me teach you. The parallelograms are the same base and in between the same parallels are equal in area. So here A, B, C, D is one parallelogram and CDPQ is another parallelogram lying on the same base CD and in between the same parallels BP and CD. Now we need to prove that area of ABCD, parallelogram ABCD, is equal to area of parallelogram CDPQ. Now first we will take these two triangles. In these two triangles, angle P is equal to angle Q, they are corresponding angles. Angle A is equal to angle B, they are also corresponding angles. And let us see PQ. CD is equal to AB because why are they equal? Because they are opposite sides of parallelogram. Also CD is equal to PQ. They are also opposite sides of parallelogram. That means what? LHS are equal, RHS will be equal. So what is PQ? PQ is nothing but AQ plus AP or PA. Similarly, AB is nothing but AQ plus QB. So in this case, AQ, if you cancel, PA is equal to QB. So in these two triangles, two corresponding angles are equal, included side is equal. So two triangles are congruent basing on angle side angle property. So when these two triangles are congruent, area of ABCD is nothing but area of trapezium AQCD plus area of triangle BCQ. And also area of parallelogram CDPQ is nothing but area of trapezium AQCD plus area of triangle ADP. We know that this is common for both. Trapezium is common and these two triangles are having equal area. That means these two RHS are equal. When these are equal, LHS will be equal. So area of parallelogram ABCD is equal to area of parallelogram CDPQ. That means what? Parallelograms lying on the same base and in between the same parallels are always equal in area. Please note it down. Now example 1, children. ABCD is a parallelogram. ABCD is a parallelogram and ABEF is a rectangle. And DG is perpendicular to AB. You need to prove that first bit ABCD area is equal to ABEF. And second one, area of ABCD is equal to AB into DG. So what is given to us? ABCD parallelogram ABCD and Let me otherwise write. ABCD is a parallelogram given. ABCD is a parallelogram and ABEF is a rectangle. And also DG is perpendicular to AB. This is given to us. Now, what is RTP required to prove? We need to prove the first bit is area of ABCD is equal to area of ABEF. And second bit is area of ABCD is equal to AB into DG. These two bits we have to prove. So let us go for the proof. First bit. Say children, ABCD and ABEF. These two are lying on the same base AB and in between the CF. Even though ABEF is a rectangle, it is also considered as a parallelogram. So I can write that ABCD and ABEF lie on the same base AB and between the same parallels AB and FC. Therefore, area of ABCD is equal to area of ABEF basing on the theorem. Theorem says when two parallelograms lying on the same base and in between the same parallels are equal in area, ABEF is a rectangle, means rectangle is also a parallelogram. So these are the two parallelograms lying on the same base and in between the same parallels. So they are equal in area. So first bit is completed. Second bit. Now we know that area of ABCD is equal to area of ABEF means what? ABEF is a rectangle, so its area is length into breadth AB into BE because BE is perpendicular. So AB into BE, but BE is equal to DG. Why BE is equal to DG? Because DG is perpendicular to AB. DG is perpendicular to AB and also BE will be equal to, see, BE is a rectangle, no? So these two are perpendicular. This only one is enough, children. AB is perpendicular to DG. Therefore, these two are equal in measure. Therefore, area of ABCD is equal to AB into, instead of BE, I am writing DG. This is the second proof, children. This is how we have proved this problem. What is that they said? ABCD is a parallelogram, ABEF is a rectangle. You need to prove that area of ABCD is equal to ABEF. And also DG is perpendicular to AB. We need to prove that area of ABCD is AB into DG. So what is given? ABCD and it is a parallelogram. ABEF is a rectangle and DG is perpendicular to AB. What we need to prove? ABCD is, area of ABCD is equal to area of ABEF, and second bit, area of ABCD is equal to AB into DG. So see, ABCD and ABEF lie on the same base AB and in between the same parallels AB and FC. Therefore, area of ABCD is equal to area of ABEF basing on the theorem. Because rectangle is also considered as a parallelogram. Parallelograms lying on the same base and in between the same area, same parallels are equal in area. So these two are equal in area. So first bit we have proved. Second bit, area of ABCD is equal to area of ABEF. ABEF is a rectangle, so length into breadth. Length is AB, breadth is BE. But BE can be taken as a DG because DG is perpendicular to AB. We can take them as equal in length. So AB into DG I have written. In the place of AB I have taken DG. In the place of BE I have taken DG. So area of ABCD is equal to AB into DG. It is the second proof. Please note it down. Now example 2 children. Triangle ABC and parallelogram ABEF are on the same base AB and in between the same parallels AB and EF. Now we need to prove that area of triangle ABC is half of the area of parallelogram ABEF. So what is given to you? Triangle ABC and parallelogram ABEF lie on the same base AB and between the same parallels AB and EF. Now what is RTP? What we need to prove? We have to prove that area of triangle ABC is equal to half area of ABEF. Here you have a construction, children. What is the construction? You have to complete a parallelogram. I can say in your textbook it is given as H. This point is H. Complete parallelogram ABHC. Now let us go for the proof. ABHC is a parallelogram. Why? Because we have constructed. Because of the construction, ABHC is a parallelogram. And what is BC? BC is a diagonal. BC becomes a diagonal for the parallelogram. And we know that diagonal bisects the parallelogram. This is the property of diagonal. Therefore, area of triangle ABC is equal to half area of parallelogram ABHC. But area of parallelogram ABHC is equal to area of parallelogram ABEF. See, area of parallelogram ABHC is equal to area of parallelogram ABEF. Why? What is the reason? Because they lie on the same base AB and between the same parallels A, B and FH. This is the reason. Therefore, area of triangle ABC is equal to half area of parallelogram. Instead of ABHC, I'll write ABEF. Hence, proved. This is the proof of this, and these are all very important topics, children. Parallelograms lying on the same base and between the same parallels are equal in area. Triangle and parallelogram lying on the same base and between the same parallels have got areas. Area of triangle is equal to half of area of parallelogram that we need. This is the property which is very useful in further problems, children. So here what is given to us? ABC is a triangle, ABEF is a parallelogram which are lying on the same base AB and in between the same parallels EF and AB. We need to prove that area of triangle ABC is half of area of parallelogram ABEF. Now here our construction is you have to complete ABHC parallelogram. In case if you take it as a parallelogram, this becomes the diagonal, BC becomes the diagonal. And in parallelogram, the property of diagonal is diagonal bisects the parallelogram, means divide the parallelogram into exactly two equal halves. So area of triangle ABC is half of parallelogram ABHC. But area of ABHC will be equal to area of ABEF. Why? Because these two parallelograms are lying on the same base and in between the same parallels. So instead of ABHC, I am taking area of triangle ABC is half area of parallelogram ABEF. This is the proof, children, important one. Please note it down. Now example 3, children. Find the area of the figure formed by joining the midpoints of the adjacent sides of rhombus with diagonals 12 centimeters and 16 centimeters. So let us draw a rhombus. Usually we draw rhombus like this. A, B, C, D is a rhombus. Now it has got two diagonals. AC is one diagonal and BD is another diagonal. AC is 12 centimeters and BD is 16 centimeters. Now find the area of the figure formed by joining the midpoints of adjacent sides. So let me take this is the midpoint E, F, G, H. These are the midpoints. So if you join the midpoints in this way, you are getting a quadrilateral. So this figure area we need to find out. So what is given to us? ABCD is a rhombus. Diagonal AC is equal to 12 centimeters and diagonal BD is equal to 16 centimeters. And E is the midpoint of AD. F is the midpoint of AB. G is the midpoint of BC and H is the midpoint of CD. Now we need to find out what is that we have to find. Find the area. What is RTP we need to prove? What is the area of EFGH? For this, you need to do one construction. What is the construction? Join EG. You have to join EG. Now, when you are joining EG, then the proof what or we can write the calculation part here. See, children, triangle EGH, and parallelogram EGCD lie on the same base. What is the base? EG. And between the same parallels, EG, EG and CD. Therefore, area of triangle EGH is equal to half of area of EGCD. Basing on the theorem or basing on the example that we have done, a triangle and parallelogram lie on the same base and in between the same parallels. In that area of triangle is half of the area of the parallelogram. So similarly, area of triangle EGF is equal to half area of EGBA. EGBA. So the quadrilateral formed by it is nothing but area of triangle EGH plus area of triangle EGF. If you join these two, you are going to get EFGH, quadrilateral. This is equal to half area of EGCD plus half area of EGBA. This is nothing but half area of EGCD plus area of EGBA. This is nothing but half area of EGCD plus EGBA is nothing but area of rhombus. Half area of rhombus ABCD. So, this is nothing but area of EGH and EGF is nothing but area of EFGH. Therefore, area of EFGH is equal to half into area of rhombus is half into D1 into D2. D1 into D2. That is half into D1, 12, one diagonal is 12, into another one is 16. 2 ones are 2 6 are, and 2 ones are 2 3s are. So that is nothing but 3 into 16, that is 48 square centimeters is the answer for this problem, children. So once again, the question here is you have to find out area of the figure formed by joining the midpoints of adjacent sides of a rhombus. And the rhombus diagonals are 12 centimeters and 16 centimeters they have given. So we have got ABCD as a rhombus. AC is the diagonal 12 centimeters, BD is the diagonal 16 centimeters. Now, E is the midpoint of AD, F is the midpoint of AB, G is the midpoint of BC, H is the midpoint of CD. So you have got the figure EFGH. You need to find out what is area of EFGH. Now here a construction is you have to join G and F. G and E. When you are joining E and G, see children, you are getting a parallelogram. This is a parallelogram. EGCD is a parallelogram and EGH is a triangle. These are lying on the same base and in between the same parallels. So, area of triangle EGH is half of parallelogram EGCD. Similarly, area of triangle EGF will be equal to half the parallelogram EGBA. So, if I take sum of these two is nothing but half of, I took half as common, half of area of EGCD plus area of EGBA. EGCD plus EGBA together makes a rhombus ABCD. And rhombus area is half into D1 into D2. So half of this is half of this into half is the formula into 12 into 16. So on cancellation I have got 48 square centimeters is the area of the figure formed by joining the midpoints of rhombus. Please note it down children. With this I am going to conclude my part. In the next class I will be doing the next part.